Hi, today we're going to be talking about Claudius Ptolemy. So, first we'll start with the first section, which is the historical context. The things I'll be talking about here is who he was, where he was born, and when he lived. So, Claudius Ptolemy was a Greco-Egyptian mathematician, astronomer, and astrologer. We know very little about Ptolemy's life because he lived way back in times AD 127 through 41. So, he made astronomical observations from Alexandria, which is in Egypt, during the years AD 127 through 141. In fact, the first observation, which we can date exactly, was made by Ptolemy on March 26th, 127 AD, while the last that we know was made on February 2nd, 141 AD. It was claimed by Theodore Melitonos in around 1360 that Ptolemy was actually born in Hermui, which is in Upper Egypt rather than Lower Egypt that most people thought he was born in. But since the claim first appears more than 1,000 years after Ptolemy's death, it must be treated as relatively unlikely to be true. In fact, there is no evidence that Ptolemy was ever anywhere other than Alexandria. His name, Claudius Ptolemy, is of course a mixture of Greek and Egyptian Ptolemy and Roman Claudius. This would indicate that he was descended from a Greek family living in Egypt and that he was a citizen of Rome, which would be a result of the Roman emperor giving that reward to one of the Ptolemy's ancestors. Ptolemy, as most people believe, lived and was born in the metropolis of Alexandria on Egypt's Mediterranean coast. Ptolemy's most famous work was the Almagest, which is an astronomy textbook and star catalog. The Almagest was an important work. It taught its students how to predict the location of a heavenly body at any time from anywhere on Earth, using Ptolemy's mathematical model of planet movements. So now that we've talked about the historical context of Ptolemy, we'll move on to the mathematical context. So here are a list of different mathematical ideas that Ptolemy is famous for. The Almagest, the geocentric theory, the geographic syntaxis, which is also known as the geographical directory, the centric model, the epicycle and different model, Ptolemy's theory, principles of cosmos, and many modern day ideas that we use today. So first, we will talk about the Almagest. It was, like I said, an astronomy textbook and star catalog. There are 13 parts of this textbook, which I will now talk about. Book 1 gives arguments for a geocentric spherical cosmos and introduces the necessary trigonometry along with the trigonometry table that allowed Ptolemy to explain and predict the motions of the sun, moon, planets, and stars. The book 2 uses spherical trigonometry to explain cartography and astronomical phenomena such as the length of the longest days and characteristics of various localities. Book 3 now deals with the motion of the sun and how to predict its position in the zodiac at a given time. Based on his observations of solstice and equinoxes, Ptolemy found the lengths of the seasons, and based on these, he proposed a simple model for the sun, which was a circular motion of uniform angular velocity, but the Earth was not at the center of the circle, but at a distance called the eccentricity from this centurion. Books 4 and 5 both address the same topic, the problem of the moon's motion. In books 4 and 5, Ptolemy gives his theory of the moon. Here he follows Hipparchus, who had studied 3 different periods which one could associate with the motion of the moon. There is the time taken for the moon to return to the same longitude, the time taken for it to return to the same velocity, which is also known as the anomaly, and the time taken for it to return to the same latitude. Ptolemy also discusses, as Hipparchus had done, the Sindonic month, which is the time between successive oppositions of the sun and the moon. In Book 4, Ptolemy gives Hipparchus's epicycle model for the motion of the moon but he notes, as in fact Hipparchus had done himself, that there are small discrepancies between the model and the observed parameters. Although noting the discrepancies, Hipparchus seems not to have worked out a better model, but Ptolemy does this in Book 5, where the model he gives improves markedly on the one proposed by Hipparchus. Book 5 describes the construction of instruments to aid in these investigations throughout all the books 1 through 13. Book 6 describes how the moon and sun's motions are related to describe solar and lunar eclipses. Books 7 and 8 are books mainly are concerned with fixed stars in the sky, giving elliptic coordinates and magnitudes for 1,022 stars. The star catalog relies heavily on that of Hipparchus, and in the majority of cases, Ptolemy simply converted Hipparchus's descriptions of the location of each star to elliptic coordinates and shifted the values to account for precision. These books also discuss the construction of a star globe. Now for books 9 and 13. These books set geometric models for the motion of the 5 planets visible to the naked eye, together with tables for predicting their positions at any given time. Ptolemy combined the epicycle and the eccentric methods to give his model for the motions of the planets. The path of the planet P, therefore consisted of circular motions on an epicycle, the centre C of the epicycle moving around a circle whose center was offset from the Earth. Ptolemy's really clever innovation here was a way to make the motion of C uniform, not about the center of the circle around which it moves, but around a point called the equant, which is symmetrically placed on the opposite side of the center from the Earth. The planetary model, which Ptolemy developed here, is a masterpiece. He created a sophisticated mathematical model to fit observational data, which before Ptolemy's time was scarce, and the model he produced, although complicated, represents the notions of planets fairly well in the book The Almagest. Now, we're going to move on to the geocentric theory. The geocentric model, or also known as Ptolemaic system, is a mathematical model of the universe formulated by the Alexandrian astronomer Ptolemy around 150 AD and was recorded, like I said, in the Almagest. The Ptolemaic system is a geocentric cosmology. That is, it starts by assuming that the Earth is stationary and at the center of the universe. The natural expectation for ancient societies was that the heavenly bodies, which were known as the sun, the moon, the planets, and stars, must travel in uniform motion along the most perfect path possible, or known as a circle. However, the paths of a sun, moon, and planets as observed from the Earth are not circular. Ptolemy's model explained this imperfection by postulating that the apparently irregular movements were a combination of several regular circular motions seen in perspective from a stationary Earth. The principles of this model were known to earlier Greek scientists, including the mathematician Hipparchus, which I discussed earlier, but they culminated in an accurate predictive model with Ptolemy. The resulting Ptolemaic system persisted, with minor adjustments, until the Earth was displaced from the center of the universe in the 16th and 17th centuries by the Copernican system and by Kepler's laws of planetary motions. So as you can see here, the Earth is in the middle, while all the other planets, sun, stars are all rotating in a circular or close to a circular motion, which contrasts what we know today, where the sun and the Earth would be basically switched. So now, onto the geographic syntaxis, which is also known as the geographical directory, as I pointed out earlier. So, this was written in 8 books. It is an attempt to summarize the geographical knowledge of the habitable Earth as known at that time, that is, the continents of Europe, Asia, and Africa. The geography was accompanied by a collection of maps, a general map of the world, and 26 others showing regional details. Ptolemy developed his own manner of representing the curved surface of the earth on a plane surface. He divided the circumference of the globe into 360 parts, or degrees, as they became to be called, and covered the surface with a network of meridians and parallels. So basically what he did here was create sort of like an atlas for all the known habitable places that they knew about back then. Now we'll move on to the eccentric model. As you can see, here's the eccentric, and this white dot represents a planet that revolves around the eccentric and the Earth. So the first principle of the Ptolemaic model is the eccentric motion, a body traveling at uniform speed on a circular path with the Earth at its center will sweep out of equal angles in equal times with the terrestrial perspective. However, if the path's center is displaced from the Earth, the body will sweep out equal angles in unequal times, moving slowest when farther away from the Earth and faster when closer to the Earth. With this simple eccentric model, Ptolemy explained the sun's varying motion through the zodiac. Another version of the model, suitable for the moon, had the direction of the line from the apogee to the perigee gradually shifted, which I will discuss in the epicycle and the deferent. So, in the Ptolemaic system, each planet revolves uniformly around a circular path called its epicycle, the center of which revolves around the Earth along a larger circular path, which is called the deferent. Because one half of an epicycle runs counter to the general motion of the deferent path, the combined motion will sometimes appear to slow down or even reverse direction, which is also called retrograding. By carefully coordinating with these two cycles, the epicyclic model explained and observed phenomenon of planets retrograding when at perigee. Ptolemy enhanced the effect of eccentricity by making the epicycle's center sweep out equal angles along the deferent in equal times, as seen as the point that he called the equant. So basically, he discovered that while also rotating around the center, which we believe back then was the Earth, the planet itself was also rotating in a perfect circle, or a little more circular, I guess. So now we'll talk about one of the biggest theories which I actually did not know of until I started reading about about Ptolemy, which is Ptolemy's theory. If a convex quadrilateral is inscribed in a circle, then the product of the diagonals is equal to the sum of the products of the two pairs of opposite sides. Now, it seems like a lot, but I will demonstrate it using two different ways, using a little sketch pad right here. So first, we want to use this to draw a circle. So let's draw a circle. Alright, so now we're going to get this away. And now we're going to draw a convex quadrilateral. So let's go here. Alright, and now I'm going to draw the lines from the diagonals. And then create a line here. And now I'm gonna write what we are trying to prove. So we're trying to prove, well, first I'll label the points. So we have A, B, C, D, and then E. So right here at the top, I'll write what we're trying to prove. We're trying to prove that AC multiplied by BD equals AB multiplied by CD plus the product of BC multiplied by AD. So the diagonals here are AC, as shown right here, and BD, and we're trying to prove that AB times, well, multiplied by CD, which are the opposite, and then BC times AD is all equivalent to AC times BD. So first, we know that triangles ABE and DBC are similar, so hence AB over BD equals AE over CD. Sorry about my C. And we also know that the angle ABD, so right here, ABD is equal to ABE plus EBD. And we know that EBC equals angle DBC, so right here, DBC plus angle EBD. Now, the triangles ABD and EBC are similar, so we know that, we also know that AD over EC pretend that's a C, EC equals BD over BC. And the result of adding AB multiplied by CD equals AE over BD, and BC times AD equals EC over BD. So basically looking at these two proportions and cross multiplying, we get AC multiplied by BD equals AB multiplied by CD plus BC multiplied by AD, which is what we're trying to prove, that the two opposite sides, the product of two opposite sides plus the product of the other two opposite sides of two diagonals are equivalent to the product of the two diagonal lengths. So there's one way to prove it. So now I'm going to get rid of all of this. Sorry, it may take a minute. And we're going to show you, and I'm going to show you a different way to prove this, which might be a little bit easier. So we're going to start with a circle again, and now we're going to make another quadrilateral inside, a convex quadrilateral inside. So here, and now, like we did the last time, make a line from the diagonal to the diagonal. There we go. But now here we're going to make a triangle on the outside. Just like that. Sort of like this. Now I'll label all the points. I won't write down everything, but no, we're just trying to prove the same thing that we were proving in the last one. So AB C D P, and then we're going to mark that these angles are congruent. So now we know that triangle ABC, so this shaded portion all right here, is similar to ADP because of angle, angle, side, angles right here. And we know that triangle BAD, which is the shaded portion right here, is similar to CAP, which is this whole big triangle right here, by of course, angle, angle, side once again. So from A, which is that triangle ABC is similar to ADP, we get that BC times DA equals BA multiplied by DP. So AB times CD plus BC times DA equals AB multiplied by the sum of CD plus DP, which equals AB times CP, which equals AC times BD. So I'll write it down just so you guys can get a little visual. AB CD plus BC multiplied by DA is equivalent to AB CD plus DP, which is equivalent to AB multiplied by CP, which that equals AC times BD, which is what we were trying to get. So AB multiplied by CB, so these two sides, plus BC, which is this side, times DA, which is the opposite sides of the diagonals right here, is equivalent to AB multiplied by CD times DA, because we were multiplying AB both times here. So we got that the two diagonals, the products of the two diagonals is equivalent to the product of the sum of two opposite sides. So now we're going to move on from Ptolemy's theory. And now we are going to move into the explicit connections, which are ideas that come from Ptolemy that we use today, which are right here. Trigonometry, trigonometry tables, spherical trigonometry, chords, ellipses, chord functions, circular motions, properties of circles, geometric models, angular velocity, epicycle models, and angles. So basically geometry and trig. So one way that I thought that we could use this in a high school classroom is by, when we're discussing trig and trig tables, is first telling our students where this all came from, how Ptolemy was able to come up with all of these different ideas and everything based on the solar system and all the theories that he came up with, the Ptolemy's theory, the epicycle and the deferent, the eccentric, creating basically an atlas, which they called the geographic syntaxis, how he used trig, circles, spheres, the properties of all of this to create the geocentric theory, as well as you can see on the screen. And then we can relate all of his ideas back to Euclid's Elements, as we discussed in this class, into our high school classroom, because basically Ptolemy got a lot of his ideas from Euclid's Elements, and he was able to create astronomical and astrological, I think that's how you say it, models just based on a lot of the Euclid elements, and he lived off of those elements. So all the resources I got, my information were from the mathematical tables in Ptolemy's Almagest, Claudius Ptolemy, which is a link I got from famousscientist.org, the editors of Encyclopedia Britannica, Khan Academy on the Geocentric Universe, the History of Mathematics textbook that we use in this course, and then history from UK biographies on Claudius Ptolemy. So thank you for listening to my presentation.